Hey y'all, today is March 22nd and we are doing a little mini lesson on tree diagrams and the counting principle. So grab a piece of paper and let's get started. So number one, Nathan is buying a new car. He can choose a car with either a 4-cylinder engine or a 6-cylinder engine. He can also choose between the colors red, blue, green, or white. Draw a tree diagram, list the sample space, and give the number of outcomes. Okay, so first of all, there are two engine options, a 4-cylinder engine or a 6-cylinder engine. So that's our first choice that we've got to make. So that's going to be my top row. So we're going to write 4-cylinder here, and then off to the side over here, we'll write 6-cylinder. Okay, and I'm going to do a little line to connect those two. Now, we also have some color options for the car. He can choose between red, blue, green, or white. So I'm going to use just the first letter of each word. R for red, blue for green, R for red, B for blue, G for green, and W for white. So those go under each of these options here. So R for red, B for blue, G for green, and W, that's a weird W, W for white. So those are the color options. And I'm just going to connect those also with some lines like so. Now, that's for a 4-cylinder car. He can choose those color options, but he can also choose those color options for a 6-cylinder car. So over here under 6-cylinder, I'm going to paste the same thing that I just made. Okay? So that is what my tree diagram looks like. Now we need to list the sample space. So I'm going to give me some room over here. The sample space. So we're just listing out all of the total outcomes, right? So the first outcome is a 4-cylinder red. So I'm going to write that as just 4R. The second outcome is a 4-cylinder engine with a blue car. He could have a 4-cylinder engine with a green car or a 4-cylinder engine with a white car. Now that's all the options for the 4-cylinder. So now we look at the 6-cylinder. So he could have a 6-cylinder red car, a 6-cylinder blue car, a 6-cylinder green car, or a 6-cylinder white car. So when I look at my sample space, I can see very clearly that I've got 1, 2, 3, 4, 5, 6, 7, 8 total outcomes. So the number of outcomes is 8. And we just counted everything in our sample space. Now I can also use my tree diagram to count the number of outcomes. So I would have counted the bottom row. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 total outcomes. Okay, so now let's look at number 2. And I think my thing got messed up when I exported it. But it should say, if the spinners, let me see, sorry y'all. If the spinners are spun, or each of the spinners are spun once, draw a tree diagram, list the sample space, and give the number of outcomes. So each of the spinners is spun once. Okay, well my first spinner has A, B, C, and D on it. So that's going to be my top row. So A, B, C, and D. That's my top row. I'm going to connect them with some little lines here. There we go. So now my second spinner, the second one is spun, is this bottom one. So remember, this one was spun first, and then this one was spun second. Okay? So my second spinner has 5 options. So it's either going to land on 1, 2, 3, 4, or 5, right? So I'm just going to connect those with some lines. So let's go like that, and then like so. Okay, so the first thing that could happen is it lands on A and then it lands on 1. Then it lands on A and then it lands on 2, and so forth. So I know that these options for the second spinner get repeated for each of the options for the first spinner. So I'm just pasting them all here using a little teacher magic. So that right there is what my tree diagram looks like. Now it does say to list the sample space, so we will do that. So my sample space, so remember it could land on A first, and then it could be 1, then it could land on A and be 2, A3, then it could be A4, and finally it could be A5. So all of the A options. Now after that, it could land on B. So we're going to have the same options: B1, B2, B3, B4, and B5. After it lands on B's, it could land on C. So we have the same options: C1, C2, C3, C4, and C5. And then lastly, it could land on D. So D1, D2, D3, D4, and D5. So that is my sample space. Lastly, it asked me to give the total number of outcomes. So number of outcomes. Well, I can count my sample space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I know that there are 20 total outcomes. I could also look at my tree diagram and get that same answer. So I know I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So either way, you'll get the same answer. Okay, let's now talk about the fundamental counting principle. So the way this works is you take the number of outcomes for your first event and multiply with the number of outcomes with your second event. And that's going to give you the total number of outcomes. So a day of the week and a number 0 through 9 are chosen at random. How many outcomes are possible? Well, a day of the week, that is our first event. How many outcomes are possible with that? 7. And a number 0 through 9 are chosen at random. Now remember, 0 through 9, that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many numbers did I just list? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I want you to remember that 0 through 9 is actually 10 numbers. Okay? So the number of outcomes for our first event is 7, and the number of outcomes for our second event is 10. So I'm going to multiply those together. So 7 times 10 is 70. There are 70 total outcomes. How many outcomes are possible? 70. Number 4, a date in the month of October and a letter of the alphabet are chosen at random. How many outcomes are possible? Well, a date in the month of October. How many days are there in October? There are 31. I know that because Halloween is the last day of October and it's always October 31st. Okay? And the letter of the alphabet are chosen at random. How many letters are in the alphabet? Well, you could list them all out and you would find out that there are 26. So the number of outcomes for my first event is 31 and the number of outcomes for my second event is 26. To find out how many outcomes are possible, I multiply these together. So I'm going to multiply 31 times 26. And I don't know that off the top of my head, but I can use my calculator. So 31 times 26 is 806. There are 806 total outcomes. Okay, let's look at number 5. The school cafeteria has 4 entree options, 7 side options, and 3 drink options. How many lunch combinations of 1 entree, 1 side, and 1 drink are possible? Well, we're just going to take what's given to us. There are 4 entree options, 7 side options, and 3 drink options. So this thing has 3 events happening. You're choosing an entree, you're choosing a side, and you're choosing a drink. So I'm just going to multiply all 3 things together. So 4 times 7 times 3. Remember, for 4 entrees, 7 sides, and 3 drinks. So I can put that all into my calculator, or I can simplify it first. I do know that 4 times 7 is 28, so 28 times 3 is a little bit easier. And I get 84. So there are 84 total combinations or total options. Okay, last one. A men's department store sells 3 different suit jackets, 6 different shirts, 8 different ties, and 4 different pairs of pants. How many different suits consisting of a jacket, shirt, tie, and pants are possible? So this one's kind of like number 5. We're going to multiply everything together. So we have 3 different suit jackets, 6 different shirts, 8 different ties, and 4 different pairs of pants. So we're multiplying 3 times 6 times 8 times 4. Okay, I can simplify this. I do know that 3 times 6 is 18, and 8 times 4 is 32. So I could say 18 times 32, and I get 576. So there are 576 total combinations possible for men's clothing at that store. Okay, and if I had just multiplied 3 times 6 times 8 times 4 in my calculator, I would have gotten the same thing. So that is the end of our little mini lesson for today. Y'all have a good day.